Hi everyone. In this video I'm going to talk to you about quadratic function transformations. In previous videos I'll talk to you about transformations of parent functions and absolute values functions. So it's going to be pretty similar to that. You just have, a different looking function, but the properties are still the same. In my earlier videos I talked about factoring, and when you factor things that are in standard form. When we're looking at transformations of quadratics, we're going to be looking at them in vertex form in this section. And vertex form is really nice because you can see the vertex in the equation. You can see the vertex in the equation when it's in standard form. So the important thing to note here is that h is backwards. So by default, it's written as a minus h. So just look at whatever the number is, and a minus h would be positive and a plus h would be a negative number. And k stays the same on the outside. So looking at this function, the g of x function, x plus 4 squared minus 1. See how it says plus 4? I'm going to reverse that and I'm going to write minus 4. And then the outside number is the same, so minus 4 minus 1, and that's it for the vertex. So looking at the parent function, the vertex is right here in the middle, and you want to get in the habit of putting it in the middle because treat your vertex like it's your pivot point, because quadratic functions are it'll be like it's going down 4, 1, 0, 1, 4, and then it's just, so it's turning at that vertex, okay? So when you're filling out the rest of the table, you can use the graphing calculator, plug this in to the graph, hit Control T, and you'll pull up the rest of the table, and it should look like this. So here's what my table looks like, and yours should look like that too if you're following along with your own calculator. What I'm going to do next is graph them, but before I graph them, I just want to go over the transformations. You can kind of tell on the vertex that the transformation is going left 4 and down 1 because you go negative 4 on the x and negative 1 on the y. What I want to make sure you know is that you can see that from the function. Plus 4 is on the inside, so therefore it's going left 4. Minus 1 is on the outside, so that means it's going down 1. So there's, a lot of different ways you can tell it, but the function, being able to tell it from the function is the important part. Okay, so I'm going to graph the original in black and the transformation in red. Okay, so your graph should look something like this, and if you notice, the vertex moved 1, 2, 3, 4 spots down, 4 spots left, and 1 spot down. Okay, let's move on to this next one. Describe the transformation of f of x squared equals x squared, represented by g of x equals x plus 5 squared plus 2, then graph each function, identify the vertex and transformations. Okay. Let's identify the transformations first. That plus 5 is on the inside, so that means it's going to go left 5. And that plus 2 is on the outside, so that means it's going to go up 2. Alright, so just making a quick little note of that there, but then I'll rewrite it over in the box. My vertex, since it went left 5, that's at negative 5. See, you reverse the sign on it, so negative 5, positive 2. So left 5, up 2, negative 5, positive 2. Alright, and that's it. There's no other transformations. There was no negative in front or a number in front to like vertically stretch it or reflect it. That being said, let's put the vertex in the middle and plug the rest in your calculator, hit Control T, and your table should match mine. Okay, so here's the rest of my table, 6, 3, 2, 3, 6. You should always see those values kind of cycling, like counting down and then after the vertex, counting right back up again. Or it could go in the reverse order where it's counting up and then it starts counting down. But yeah, that's how you know you did it right. And if you were just looking at a table blindly, then you kind of know that's where the vertex is, because you can tell where it turns. Anyway, I just need to graph the original and graph the transformation now. Okay, so here is my graph, and if you look at it, all the points moved left 5, up 2. See, let's take this point right here. 1, 2, 3, 4, 5, up, 1, 2. And the same is true for all the other points. All right, let's move on to the next page. Let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x equals x squared. Write a rule for G and identify the vertex. Okay, so it says vertical stretch by a factor of 2. So I'm going to write down a 2. And what else does it say? It says a reflection in the x-axis. So you want to put the 2 by the x, and then with the reflection in the x-axis, that is going to be a negative, and that negative is going to be out front. Remember, if the negative were on the inside, it would be a reflection over the y-axis. So now it's going to say negative 2x. And now I just need to determine, am I going to have parentheses here because it's moving left or right, or am I going to add a number on the outside? And if I do that, I don't need parentheses. It says 3 units down. That is not on the inside. That's completely on the outside. So, excuse me, I'm going to put minus 3. And then, since this is a quadratic function, just don't forget to write your x squared. I waited on that because if I hadn't done that, and this were moving like right 3, it'd look something like that. But that's not what's happening here, okay? So I'm just going to go ahead and erase this and put the squared back where it should go. Okay, and then every time you write a function that's transformed, it goes from f to g. So you just throw in a g of x there. That's why it says write a function of g, or write a rule for g. So there's your function. Negative 2x squared minus 3. What's the vertex at? Well, remember, the vertex is at h comma k. So was there an h? No, there was not. How do I know that? Because the h is the number on the inside of the parentheses. See? So let's go back and look at this. H is the number on the inside of the parentheses. There were no parentheses, so therefore h must be 0. And then k is the number adding and subtracting on the outside. In other words, not in parentheses. So the number on the outside was minus 3. So my vertex is at 0, negative 3. And that's all I have to say about that one. So let the graph of G be a translation 4 units left and 1 unit down, followed by a reflection in the y-axis of the graph of f of x equals x minus 1 squared plus 8. Write a rule for G and identify the vertex. So translate 4 units left means I'm going to add 4 to the inside of the problem. So I'll put a little plus 4 right here. Okay? 1 unit down means I'm going to minus 1, and I will do that on the outside of the problem. All right? And then followed by a reflection in the y-axis. So y-axis reflection is going to be a negative on the inside. If it were on the outside, it'd be an x-axis reflection. Okay? So now I just need to rewrite my function with these numbers represented. So I have g of x equals, see how I changed f to g, negative x plus 3 squared, and 8 minus 1 is 7, so plus 7. Okay? Now, let's identify the vertex. So the vertex on this one is, the last one or in the previous ones as well, you look at the number on the inside and you flip the sign. So I'd write negative 3, and then the outside number is positive 7. But this one is actually positive 3 and positive 7. And so if you're wondering why, it's because we reflected it across the y-axis, so it flipped sideways. So let me show you the graph of this to give you a visual representation of what we're looking at here. Okay, so you can see that the vertex did move 3 spots to the right and 7 up. Again, it was supposed to be 3 spots to the left and 7 up, but because you reflected it over the y-axis, it moved over to the right side. It's like, opening and closing a book when you reflect over the y-axis, okay? So just be on the lookout for that. If you see like a negative in front of the x, you have a y-axis reflection, and so your vertex is going to be, opposite of where you would think it would be. Okay, so with the rest of these, I want you to try these on your own and pause the video right now, and then when you unpause it, you'll see my answers, and hopefully you got the same answers. Okay, so with this first graph, the negative made it reflect over the x-axis, the 1/2 made it vertically compress, so it didn't move it left or right at all, so my vertex stayed at 0, 0. I didn't add or subtract anything to it. So my graph looks a little bit wider, and it's opening down, and these were my table values. Not sure, I don't know if it looked blurry to you or not, but it looked blurry to me, but then it snapped into focus. Not sure if you saw the same thing. This app is a little weird sometimes. The next one, vertical stretch by a factor of 3 with that number in front. The -1 made it go right 1, so that means the vertex is going to go to 1, 0. It didn't add or subtract anything on the outside. So you see the graph is a bit skinnier, and these are my table values. The next one went 3 units right, 2 units up, followed by a reflection of the y-axis. So reflection of the y-axis, negative on the inside, 3 units right, -3 on the inside. 2 units up, add 2 to the outside, and you get this negative x minus 3 squared graph. And so my vertex is at -3, -3 because of that y-axis reflection again. All right, and then the last one was just 1/2 times x minus 2 squared because of vertical shrink by a factor of 1/2 followed by translation of right 2 units. So that made my vertex just go to 2, 0. There was no reflection on the y-axis, so it was a normal looking one there. All right, I hope this helped. Stay tuned for additional videos. Goodbye, everyone.